Hello, 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 hello. Hi everyone. Today is my this is the day 38 of my C++ DSA journey. In today's stream, that is the day 38 of our C++ DSA journey. In today's video, we will revisit some problems and also do some new problems. Okay. And according to the roadmap, we are supposed to do only one new problem today, but we will see. We will go with the flow. If stream time like the stream not stress to that time, then we will take more new problems because I was thinking to do binary search in a good manner. Okay, just wait. Let me share the link in the Discord. So and welcome all to the day 30th stream of my C++ TH journey. Yeah, and also at the same time, like practicing new words for starting the stream. Like uh, testing some variations to welcome all the audience or other things. So yeah, this is a you can say a experiment with the words. Just wait. Hello, hello. Mm, hello, chat. So now we will do the new problem of today. Okay, that's name is next permutation. And in this problem, like I've understood it yesterday, but first I will add the code. After that, I will explain you what is happening. Like if I tell you in this example, okay, like we have to switch some values and make the value shorter. Okay, by switching the order of some value. So we will write the code for that. Okay. So for that, I will be writing a code in which the time complexity will be big of n. Okay. So first, like here, there is no good example given here. So we will take another good example to understand how next permutation works by using Excalibur. So, okay. First, we have to find a pivot where we will go pivot. We'll go from the zeroth index till the oh sorry. We'll go from the last index mm, to the first index I minus minus, and after that, if Yeah. Nums I is less than nums I plus 1. And then okay, we have to create a variable also named as pivot. So pivot in the starting it will be initialized with the -1, and here if it's this true, so we will so pivot will be equals to nums I. Okay, and then we will break when we'll find the pivot immediately after that, and after this for loop we will check if pivot is equals to -1. In that case, we have to reverse nums dot begin and nums dot end. Nums dot begin, nums dot end. Okay, and just simply return because we are doing in place sorting, right? And after that, yeah, we get the pivot. When we get the pivot, then after that, we found the last index for that. Sorry, we find the next greater element means next greater element for int I is equals to n-1 means from the last index I is more than pivot. Okay, because it will be after the pivot index, right? So I minus minus. If the nums index value is more than pivot, in that case we have to swap. We will swap nums I with the pivot, right? Okay, wait. Pivot index. Okay. Then after that we were supposed to for integer I is equals to pivot plus 1. Uh, I is less than n-1 I plus plus. Every time in this we swap. Oh wait. I think I'm forgetting code a little bit here. So yeah, after finding the pivot and the next greater element that will be on the last of the array. Okay, then we have to swap the values in between those. So to swap that, okay, it will start from pivot plus 1 and go to the second last value that we have done for this, and we will swap. Just create the, I think I forget the swap logic. Hmm. Oh, okay. Instead of this, we will use while loop, right? So we will create two variables. While I less than equals to j, we have to swap nums I value with nums or j value. Compiler end of declaration where okay. Mhm. Redefinition of file. Okay. Okay. Instead of that, I will name it. I will give it another name. K or K and G. Okay. So here it will be K and G. G. Oh wait. It's passing one test case. The last value is being not being swapped. So these two values are not being swapped. So I think wait. Hmm. Yeah, it will be error filtered nums project value. There will be nums event. Mhm. Yeah. Right. I will now ask it from Copilot. And why I'm asking, I think we can do it by self. Let's see. We found the pivot and then I used the break state. Okay, okay. Instead of I think the mistake is being here. Oh, you fixed a single mistake. Next greater element, we have to found that. So I is equals to n minus 1 means the last index, I minus minus, and I is more than pivot. Hmm. If I is more than nums pivot, then we will swap those values, right? or less than. Okay, wait. I think it was the less than. Time limit exceeded. Swap num_psi with num_py with break. Integer k is equals to pivot plus 1. J is equals to n minus 1. Yeah, but it will be. Hmm, don't give me the code. Got it. Let me walk you through where the things are going in wrong in your logic. Pivot loop and checking them side problem I is equals to n minus 1. You are choosing them. Okay. The loop should start from n minus 2. Yeah, n minus 2. But yeah, then we can check for right, like I plus 1, right? Pivot storage, we are storing pivot is equals to, but we are finding pivot, then why we are doing that? Okay, so that we can compare, right? We are comparing, so it will be fine. The next creator element group you wrote, but pivot should be the index, I not the value. Just storing pivot is, but pivot should be the index of I, not the value. You are treating pivot like an index. Okay. Yeah, pivot is showing as a index, right? Okay. That's when pivot is an index, but it's told that when this condition is wrong, compare indices, not values. Oh, reversing suffix. After swapping, you need to reverse the subarray from pivot plus 1 to end. In your code, you wrote to do the while k is less than equals to j loop, but forget to increment k and decrement k. Okay, yeah. K plus plus and j minus minus. Because we are swapping values, right? So, okay. Wrong answer. 132. So in this case, pivot become 1. Okay. So see, pivot become once, and the next greater element to that was 2. So we pick 2 as the next greater element and swap both nums pivot and then that value. Like here, when we find the next greater element, we do that. Expected was 213. Just giving it's swapping logic. I think there is some mistake in swapping logic. It's really test case I think there's some mistake in swap loop, yeah, or third loop. Okay. The mistake is in the third loop there. So let me explain. The pirate finding part is now correct. Your storing index, not the value. The swap with the next letter. Okay. The issue is that you put the reversal loop inside the for loop. Oh, wait. This for loop is closed here. This for loop is not closed here, right? Hmm. Yeah, this for loop is not closed. So I will remove this and now we will close this for loop. It should be now I think the code is correct. Okay. I'll just submit it after, yeah, and just I will take a 5 minutes of break. After that, I will explain what is given as the problem. Okay, because I also have to finish the evening lunch. Like I have got the evening lunch, so I will finish that. Time complexity of code will be big of n because we just use for loops, right? Two pointers and simulation. Like in this problem, we do that, and time complexity of big of n. What we are doing here there was finding pivot swapped with next data element and a reverse suffix to get the next lexicographical permutation. Okay, we will try to understand that by the help of AI and also I will use Excalibur for that. So, just wait. First, new. According to the roadmap, we have done the number of problems that we were supposed to do today, but yeah, we will go with the flow and I will take new problems also. So now 5 minutes of break. Okay, because I have to finish the lunch. Like lunch have already been come, but it's getting cold, so I think I should finish that because there are some breads, you know, and yeah. Till then, you all can try to see the code and understand what's happening. Maybe you get a hint. So just wait. I will be back till the break ends. And after the break ends, first I will revisit the problems. Okay, like in which binary search will be applied as answer. I will first explain that on a problem and after that I will write the code of a problem maybe. And after that we also have to do the third revisit of today in which yeah we also did have to understand what was happening in that problem because I wasn't unable to understand the logic of the pointers moving in that binary search problem. Name was search index sorry. Okay, its name was search insert position. Yeah, its name was search insert position. Till then you all can just try to understand the code. Try to understand this part of the code, like how we are finding pivot. Okay, I will explain the problem first with Excalibur. Okay, with a simple example, how we are finding those values, how we are swapping these, what's happening after that. So I think I should keep the mic a little far from me because the voice is very much dangerous. I think so. Yeah. Till the break ends, you all first try to see the code. Okay. I'm just turning off like till the break ends. We are back. We are back. We are back. So now we will. What I will do, I will take example to explain like how this code will work and what it will do. Okay. Like here's an I think good example given. Suppose there is an array given. Their values are 1, 2, and 3. The following are the permutations of that. Okay. But we have to find the next permutation. Okay. We don't have to find all the permutations, possible permutation. Okay. We just have to return the next permutation of any given array. Okay. So here, like suppose it is 1, 2, 3. Okay, choose first it will be 1, 2, 3. Then after that it became 1, 3, and 2. Okay, we swap these two values and it became 1, 3, 2. After that, we took take 2. You can, I think you can see the pattern. We take 2. After that 1 and 3. And after that again it started with 2 and after that 3 and 1. Okay. Then after that it started with 3, 1, 2. Then 3, 2, 1. Hmm. And how we can find the next permutation? There is a formula for that I have written here. Okay, like how we can find the next permutation for any for any arrangement of numbers. Um, just let me take a good example. That is, just wait. Okay, I'm taking an example from the lecture that I have like read from. Mm, wait. Mm, what? Mm, okay, first I will. um, yeah, first I will take that array on which we will be performing that. So it's 1, 2, 3, and 6, 5, 4. 1, 2, and why we are taking an okay because it will be an array 6, 5, and 4. Hmm. Hmm. Okay. Wait. So how we are applying the code and how we are finding the next permutation will be like in this case. Okay, you can see these values are sorted in a manner like in ascending order. Okay, so if all the values will be in ascending order, then it will be the Okay. And first I will tell you how to find the pivot index. Okay. Like how we can find the next permutation for that. And I will also add this example in the dry run. So to find the pivot index, we traverse the array in the backward direction. Okay. Like you can see, when you go backwards again and again, then you will find that like these values are in decreasing order. Okay. Like increasing order from here, but when we go forward, it is in decreasing order, right? 6, then 5, then 4. But here you will see after this point, this value is more than this. Okay, so nums I is more than nums I plus 1. So this will be the point, like this will be the pivot index. So pivot. So for calculating pivot, what I did, I just write the code for this like this. Um, I is equals to L minus 2, I is more than 0 or equals to 0, I minus minus. If nums I value is less than nums I plus 1. Why I've done that? Because we have to get the next greater element, and in that case, when we check for nums I is less than nums I minus plus 1, that means index, like we are traversing the array from this. Okay, so this will be the element which will be greater than that. So the pivot will be um wait, pivot will be pivot will become in this case as the 2 means second third value. Okay, third value's index, that is 2, because we start the indexes in programming from 0, 0, 1, 2. Okay, pivot is 2, but then after that, okay, we got the pivot, right? And if pivot is minus 1, okay, suppose after they get doing this, if we not find the pivot, then if it's equals to minus 1, that means we don't find the pivot. In that case, it will be it will mean that okay, the array is in like a descending order. Like it is already in descending order, like all the values were in descending order. Okay, we try to traverse them from the start. Okay, sorry, it's yeah, it's in decreasing form when we start traversing the array from the first to the last. So, and if we even try to find the pivot, then we go backwards and we not find any value at any point that okay, the previous value is less than the next. Okay. But in this case, we found that this is the, so in this case, what we do, we just reverse the array, okay, to make it, yeah. I will show you that example also. Maybe I have also just understood this problem from the lecture. And for finding the next greater element, what we do, we run a backwards loop and we get the next greater element, and just we swap nums I with pivot. Okay, so here let's greater element. Okay, so I will limit as next greater element is equals to what? It will become 4 because it is more than 3 when we will compare that. So it is 4. Okay, now it will swap. We have to swap this value and this value. Okay. So after swapping the values, the array will now become like 1, 2, 3, 6, 5, and 4. Oh, wait. It will be 3 because just swap the values. And in place of 3, it will be 4, right? It will be 4. Okay. Hmm. Now what we do after that, we do swap the values between pivot plus 1 and we have values from pivot plus 1 to the last index, right? So pivot is this, pivot plus 1 will be this. Like we swap these two values, okay? We will swap these two. So after swapping, it will become 5 will come here and 6 will come here, right? So 1, 2, 5, 6, 3. Wait, something is getting wrong, I think. Okay, yeah. We also have to take the last, right? We did have to take the last also. So when we will do that, so it will become after swapping it, here also swapping has done. Swap part 2. Like we are swapping this after swapping like the pivot and the last next greater element. Okay. After swapping, it will look like here 3 will come, here 6 will come, right? So here it will be 3, here it will be 6, and 5 will be in place, right? So after swapping, it will become 1, 2, 4, and 3, 5, 6. And now if I show you 1, 2, 3, 6, 5, 4, right? 1, 2, 3, 6, 5, 4. 1, 2, 4, and 3, 5, 6, right? Like what we got here. So this is how this thing is works. Hey, can you tell me uh, what is next permutation? I just want to explain it uh, explain it to my viewers. It's about rearranging the numbers into the next lexicographically greater order, right? Like 1 to 3 becomes 1, 3, 2. It's not like greater arrangement exists like 3, 2, 1. Then we reset the lowest order 1, 2, 3. Step by step intuition is this: we find the pivot, scan from right to left, okay, from the last to the first, find the first index where nums I is less than nums I plus 1. This is the spot where the sequence can still be made bigger. Then we find the next greater element. From the right side, find the smallest number that's bigger than nums pivot. Okay, swap them. We swap them. We then reverse the suffix. Reverse everything after the pivot index. This ensures the sequence after pivot is the smallest. Okay, so overall, it's the next permutation, not just any bigger one. Example for all of you is take 1, 2, 3. Pivot is 2 here. Okay. Since 2 is less than 3, we had solid in ascending order, right? So next criteria element is 3. So we swap 3 with 2. Reverse suffix, nothing much here, just 1, 3, 2. Take 3 to 1, no pivot found. We reverse whole array, we get 1, 2, 3. Okay. One next permutation is the algorithm to arrange numbers into the next bigger sequence in dictionary order or reset to the smallest if no one exists. Okay. Um, Give me a good one-liner explanation. Next permutation means rearranging numbers into the very next bigger order in order sequence in dictionary sequence, right? Or resetting to the smallest, and if that don't exist, then we reset to the smallest if none exist. It's short, clear, and perfect for view. Okay. Just take 1, 2, 3. Okay. No, no, give me all possible permutation of this. See, these are all the permutations that can done. So first it was 1, 2, 3, then it became like the first value was 1 after that also, but we did 1, 3, 2. Then after that it became 2, 1, 3 means first value changed from 1 to 2. We upgraded that, and after that 1 and 3. Okay, then 2, 3, 1 means the next bigger value according to the thing that said for three numbers there are three. Okay, factorial 6 total permutations starting from 1 to 3. The next permutation algorithm moves step by step through this process until we reach 3 to 1. Then it resets back to 1 to 3. Like here it is 2, 1, 3. Then it become 2, 3, 1. Then after that we take 3, 1, 2. Then 3 to 1. Okay. Like we keep doing that until I think we reverse the whole number, right? Like we eventually next take the I think next bigger number by using those values again and again until we reach that number which is biggest in these, right? So we take a number and get the next bigger numbers using those digits and until we reverse the whole value into biggest possible, right? Oh, we take then we keep rearranging the its digits to form the next bigger number in dictionary order. We continue this process until we reach the biggest possible arrangement, 3 to 1. After that, the algorithm checks resets back to the smallest 1 to 3 and cycle repeats. So next permutation is just moving to the next bigger arrangement of digits. Once you hit the maximum arrangement, you flip back to the minimum. Okay, now give me on 1, 2, 3, 6, 5, 4. Okay, now we'll take our example and check all the possible permutations. Give me all permutations for this in short. Oh, 720. That means we can arrange this in a 720 different arrangements of those digits. Listing all 720 here would be super long and not practical intent, but here, how you can explain it? Okay. So on until we reach this one ladder. For 6 digits like 1, 2, 3, 6, 5, 4, there are 720 possible permutations, right? And the next permutation algorithm works through them one by one in dictionary order. So that's why we are doing the next permutation, okay? Like we just have to return the next permutation like this. Okay, wait. Like this. Then after that, if you see, okay, this is again in this order. And that's how we do this. Okay, find the pivot. Then if pivot is -1, then we reverse the whole array and return just return, not return the thing because we are doing in place sorting. After that, we find the next greater element by doing this, and then we reverse values from pivot +1 to the end. Okay. Um. Man. Now we will revisit the problem. Okay. Name of the problem is okay. I will revisit it here, okay, by not writing the code, but we will write the code for the next revisit because that is also the same as this, just the variable names have changed. So what we do in this, we just do the opposite of what we did keep doing in book allocation or find split array largest sum, or you take painter's partition problem in which we try to find the maximum of the minimum of the maximum, okay, but in this case that is opposite of it, that we try to find maximum of the minimum, okay, like there will be distance given, there will be, see, assign the curves to the stalls such that minimum distance between any two curves is maximized, okay, means minimum distance should be maximized so that they don't fight it, so the chances of their fighting will be less because these are aggressive cows. The far they will be from each other, the less there will be chances of being like fight right between them. So for that we do take a variable n, okay, then after that we sort the array because these are the stalls, okay, in which we can place the cows, and stalls are not sorted here, so we will first sort the stall, then it all will come in order, then we can apply binary search on that, not on that, but yeah, when we will place the cows, then it will be needed. So we choose the first and start and value, like it will be a range of possible answers, and there should be minimum two cows, right? And by default, the first cow will be on the first zeroth index, like the first stall, right? So we take first stall, start with 1, and end is equals to, like, because there will be minimum two cows, right? So that we can check for if they will be aggressive or not. So we can place, for example, we can place first cow on the very first, like first stall, and we can place the last cow, the second cow on the last index, okay, with the, like it is showing the bigger value, so it will be 9, okay. So when we calculate the end, and will be 9 minus 1 because there will be two cow placed, so the distance will be 8 units, right? If it was 1 and 10, then distance should have been around 9 digits. Oh, sorry, 9 units. Then we take an answer variable. Okay. After that, we calculate the mid by doing this, and now we check if it's valid or not. If it's a valid, okay, if it's valid answer, if it's valid, then we answer is equals to mid and start is equals to mid plus one. Like, because we have to do return the maximum of the minimum. So if that's true, we check for more bigger values. If that is valid, in that we return the most bigger distance. In that we can arrange the cows. And in that case, if that's not true, if it's invalid, then we check for the shorter values. Okay, like the smaller values in the array. And for checking if it's valid or not, we do this. Like we try to place the cows, and yeah, there is a two variables. First, there will be one cow by default. Okay, we will place it in the very first position. Then we run a for loop from that position to the I plus to the last of the array. Then we check if array minus last stall means array index minus last stall, because in last stall we are storing the value of array. Okay, like this one. So when we do that, if this is more than or equals to minimum allowed, means minimum allowed is the middle we get. Okay, that we are checking for. If it's that's true, so cows plus plus and last stall. Hmm, last stall is equals to array of I. Okay, after that, if we keep doing that, and in the end we check return if cow is more than or equals to, okay, the cows number should be equals to the original number of cows that we are checking for. Okay, then we return true. And if we not return it will be by default. I think that will be, we will check for it in the smaller values. In the end we return answer. By that, doing that, we get the mm, maximum of minimum distance between cows. Okay, and why I not like exact explain this too much or explain this in a detailed way, because I have already like it in my mind, the pattern of it and how the things will work. Okay, wrong answer. But I think I just maybe by mistake made some changes in the result. We have marked it as revisited. Okay. Mm, like we are trying to find at what max distance we can place the cows. Okay, according to the allowed yeah minimum allowed distance, right? So we do that, and in the end we check if it's okay, and we keep updating the answer if we found the valid answer. Okay, then we keep checking for the bigger values, so like the bigger distances. If that will be possible, that will be more good. And we in the end we return the answer like this. um, like we skip that, like we skip that stall. If that stall well distance is less than minimum allowed distance, okay, then we skip that stall and try to place that cow onto the other stall, like this. That's why we are also sorted the array, so that we can check for on which we have to place the cow, and the current order we get the answer, right? I am like focusing on strings. Like today I will start to learn about strings because the problem we have done today is already, I think binary search is done a lot, but there will be two, three problems of binary search that we can do or explore. Okay, so first problem revisited. Name was this aggressive counts, right? Okay, this is done. Now we'll revisit the second problem of today. Name was hmm, yeah, magnetic force between two balls. Okay, this is same as aggressive cows. In this I will try to write the code. Not try. Should we try it or okay? But I think there is no means, right? To try again the code. Like try to this. It is not mandatory to write the code again and again, right? Because if suppose I've done this aggressive cows problem, okay, after that I again did this problem, then I think we can mark it as revisited, right? Like when I know the logic, why I will have to do that, right? I can write the code, and it will also save my time, and I think it's also not that much stress. But yeah, let's see. And how we get the range in this, I've already told you. And why after that getting the range, why we do that? Because there will be not only two cows, right? Maybe there will be three cows. Then how we will place those cows? So for that we get the mid and check for the things like how we will place the cows. Um, okay, we can write the code, man. There is no much that much difficult, right? Um, so first I will write this part of the code that is okay. We will take an variable n is equals to nums okay, post dot size. Then what we do is we take two variables. Start is okay. Wait, start is equals to 1. Yeah, start is equals to 1 and n is equals to n minus 1 minus post like the zeroth index value, right? Then okay, before that we also have to sort the error. We can sort it here. Sort post dot begin and post dot end. Okay, we sorted the error. Then after that, okay, we have taken start and end. Now we will apply the while loop. While start is less than or equals to end, we have to run the loop till then. And inside this, we are checking if okay. First we will, and before this, we will create an answer variable. Initialize it my minus 1. Now we will check. Now we will calculate the mid, right? Integer mid is equals to start plus n minus start divided by 2. Then after that we check if is valid function, right? If it's valid function, if it's true, and this we will pass the values of post k and mid. And here it is already been done. We will not change this. We will just try to rewrite the code inside this. Okay. if it will be valid, then answer is equals to mid, and start is equals to mid plus 1, right? Like we check for the bigger values in the right side of the array. Else, if that's not true, end is equals to mid minus 1 means we keep checking for it, like for the smaller values for it, right? In the end, we return answer after this while loop. Answer. Now we'll add the code for this part. Okay. So balls, like there will be by default a one ball, like what we do in cows, and also last position is equals to post at 0, right? By default, it will be on the very first. So after that, we use for loop. I is equals to 1, I is less than equals to I is less than n, I plus plus, not n man. We post dot size, right? Post dot size I plus plus every time it's happening. Then we check if post I minus last position, and we check if it's more than or equals to minimum allowed. If that's true, in that case, balls plus plus and last position will be equals to post I, right? And in the end, we check return ball k, right? But it will be not more than, right? Maybe it will be always equals to, not more than. Maybe if we try k, okay, post mid m. Okay, instead of k, we have to return check for m, right? Here it is given as m. Mhm. Lambda capitalist n minus 1. Lambda capitalist. Oh, okay. We also tell like from where like try to access the value, right? N minus 1. Here it is, what's the name? Undeclared identifier k. Instead of k, we have to give m, right? Okay, it's subsetted. If I try to, maybe if I remove this, will it work? Okay, it's giving wrong answer. Why? Why? 3, 6. Output is 6. Expected was 3. Now this is the thing that we can ask for. Why we do this? Like, don't we like we are checking if balls after placing is equals to original numbers of balls right in magnetic distance between two balls of problem. Okay, if we place m or more than m balls, which is feasible. If balls are less, then it's not feasible. Okay, we are not checking for equal, we're checking for if it's greater than or equal to, okay, original number of balls. Okay, fine. Time complexity of the code of this will be big of n log n plus n log d. And this will be the same for, I think, that problem also. Like we can say it as big of n log n, okay. In both of these two new problems that we have revisited, name was magnetic force between two balls. Now the second revisit is done. Second problem revisited. Now I will give some time in third revisit because I also have to understand that. Okay, after that we will try our new problem. Mm, That name is search insert index. Okay. First, I will try to analyze what is given, like what I wrote in the code yesterday. Okay. Array is already sorted. If we see, we get to the middle, and if middle is less than target, then we go in the left side, right? Like this part. Okay, here 2 is not present. Okay, so middle will be this value 3. Mm, Start become this, but okay, it's giving 2 in the output, so it will be 2. Okay, here in this case, start is equals to mid plus 1, right? Okay, but it's not less than target, right? Nums mid, when we get the mid, it's not less than target. If it's more than the target, then we do end is equals to mid minus 1, means what? End becomes mid minus 1 means mid is this. If mid is this value, then end minus 1 becomes what? End minus 1 becomes this value, right? Like 0, end is at the 0, and start is also at the 0, right? So in that case, if we see, now we'll compare mid. Okay, we get the mid as 0. Mid value is 1. Okay, when we compare it with fit target, it is less. It is less than the target, right? So low is equals to mid plus 1 means this index. And now we have traversed the array, I think, like this is the last value, right? And then we are returning low as the pointer end. It's pointing as the second, right? 0, 1. Okay, in this case, it's pointing at 1. That's how it's working. Okay, so mm, 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 mm. Okay, just we are applying simple binary search on this problem, right? So we take two variables. Start, I will limit as start, okay, not low and high, 0. And n is equals to n minus k nums dot size minus 1. And after that we calculate like used while loop while start is less than or equals to n. Okay, then after that we calculate the mid is equals to start plus n minus start divided by 2. After that we check if nums mid, if it's equals to target, in that case we will return mid index because we have to return the index. If nums mid is less than target, then in that case we do check for it in the left side, right? Yeah, in the else, if, okay, not if, it will be else if. In the else case, we do check for it in the left side of the array means this while loop ended here. After that we return loop. If in any case there is target is not found, then we will return the index on which it should be found. So for that we are returning loop. If nums mid will be equals to target, okay, nums mid value will be equals to target value, then we will return mid index, okay, as target is found on that index. But if not, return the index where it would be found if it were inserted in order, okay, in a sorted order. So you have to find that. So for finding that, we do use binary search. We take the very first and last value. We calculate the mid for that. Okay, like in this case, suppose this. Okay, we calculate the mid. Mid will be 3 here. Okay, mid will be 3. Then we compare is it if mid is equals to target. Okay, it's not equals to target. Then we will check if in the else if case is nums mid is less than target. Yes, it is not less than. It is more than target. Okay, it is more than target. Then we again shift the end is equals to mid minus 1 means end was this and end was this. Okay, now end will become mid minus 1 means mid was this, so end will become this part. Okay, and start is also at this point. So when we will calculate that mid will be 1 like this index. When we will check if nums mid is the less yeah, in this case nums mid will be less than target because 1 is less than 2. Then in that case what we do start is equals to mid plus 1 means start now have come after end. Okay, and on this start have become mid plus 1, and this loop will end when start will be less more than end. Okay, and then we are returning low, not low, it will be start, man. Yeah, it will be start. Okay, this is how this thing is to be being done. And wait. Like, okay, start and end or was on this index. Okay, then we check for that. If nums mid is more than or equals to or less than target, then it was less than the target 2. Okay, because value is bigger than 1. So if it's less than target, then we do end is equals to mid. Okay. Wait, man, wait. Okay. Then we do end is equals to mid minus 1 means, oh, okay, wait. I will again do the try run. Okay. We get the middle value. This like this. This will be the middle value. We compare that it's not equals to target. It is more than target. Okay. Then end becomes mid minus 1 means end have become this, and also start had is already on this index. When we will calculate the mid again, it will be, oh yeah, it will be at point at this value. Okay, if nums mid value, when we will check for it, if it's equals to target, then it will not be equals to target because target is bigger. And when nums mid is less than the target, okay, then that case we do start is equals to mid plus 1 means end was also on this point and start was also on this point. So start is now become mid plus 1. Okay, and when start will become mid plus 1 means we are on this index. Okay, but we will then this condition will say that start should not be equals to or like not be more than end. Okay, so in this case start will be more than end, like start will come at this point and we are returning start at the end, and when we check start, that is what, that is okay, we found the target to add the second index, that is like index is 1. Okay, like this is the 0th index, this is the 1st index. So if 2 was inserted in the order, then it will be on the second value, right, as a second value. 3 will be on third value. This is how we check for it. Yesterday it was not getting clear, right? Time complexity of the code will be big of log n because we just did use the simpler binary search in this problem. Okay, and now I will mark it as revisited. Third problem revisited. Name was search insert index. Now what I will do, I will take a 2 minutes of break, and in between the break we will find the problem, the next problem that we will solve. Okay. Break started. Like I have some problems in my mind. I will just discuss it. Okay, why not discuss this, man? Why even I am taking a break? Let's leave that. A break is not needed. Hey, you tell me now which problem should I pick from these? Search in rotated sorted array, part 2. Okay, there's also in part 2 of it, and find minimum in yeah, rotated sorted array, part 1 and 2. Let's compare the effects partly based on the time energy spent today. LeetCode. Variety of rotated search, but with duplicates allowed. Trick. Nums mid is equals to low, low is equals to high. You can't decide which side is sorted. Need to string boundaries. Okay. Pick minimum. Okay. Find minimum in sorted array. 1. It's medium clean and safe. Search in sorted, rotated sorted array. Second, okay. When you are ready for trickier duplicates. Like I know about binary search. Okay, let me paste the number of problems that I have done already. Done these problem. Now, or tell me on that basis, because okay, find a minimum in sorted array first. Okay, first we will do see that. Oh wait. 60. Mm, if it's string 60 here, it should be 60, right? Okay. Yeah, let me see that problem first. Not this song. Okay, it was here, right? So find minimum in sorted array. Whew, let's do it. Mm, just I'm trying to think about the logic. Like, yeah, we will use binary search, right? Nums dot size. If we see that problem in which we did no. Mm, search in rotated sorted array. This was the code that we wrote for it. Mm, we applied binary search, then okay, we check, but we can't check like this, right? If it's because there is no target given, we have to find the minimum. So, and we can't use loop. Mm, mm, mm. Hey, I got to a point in minimum in sorted sorry, sorted, not sorted, rotated, sorted array. I think maybe there will be binary search 2 times be used, but I got to a point and got to no. Okay, now there is no target given. We have to find the minimum. First, I know we will check for it in the sorted part, and I think maybe pick the smallest value from that and compare it with the value of unsorted part. Oh, really? We are thinking in the right direction? Oh, okay. Checkers array is sorted. Yeah, that is true. Like we always choose the unsorted side because it will not be in the sorted part, right? Because its smallest element is already known. If we see that, okay, minimum was always present in the unsorted part, right? No, the sorted part. But here, after this, right? Because after this, the sorting. Uh, okay, first we calculate the mid. While start is less than equals to end, mid will be start plus end minus start divided by 2, and now we have to check if nums mid, okay, nums not nums mid, right? Okay, if nums no start is less than or equals to nums end, we will return mm, start, right? Because in that case the whole array will be sorted, but okay, in this case no rotation. Binary search for we calculate the mid. If nums mid is more than nums equals to low, that means okay, left part is sorted. Yeah, because when we compare mid with this, it will be shorter and it will considered as this is the sorted part. But the minimum value will be in the unsorted part. Okay, if nums mid is more than equals to nums start, right? That means it will be in the right side means start is equals to mid plus 1. Okay, then what we do? I think we do compare, right? Else right part sorted means okay. If maybe right part is sorted, then in that case will be else if, right? Else end is equals to mid minus 1. But what we did do return then loop ends when low is equals to high. At that point, low points to the minimum element. Okay, but you have to return something. What you will see on this code. Stream is I think a little bit off today, right? It's going in a very off streams. Return statement. This statement returns the index start instead of minimum value. Okay, should be num start. Okay, we have to return the value, right? Not the index. Loop condition. But in problem, the standard approach is start is less than end because we want to convert start and end to the minimum index. With we are forcing extra checks and may miss the final maximum. Okay, in that I think we will return the start, right? If I do return the start here, start is equals return start. Sorry, nums add plus start. There is an extra curly brace. Hmm. Oh, it's accepted. Hmm. Was it that easy? I just taken your advice and changed just return start to nums start. Other changes have done by myself. Okay. Issues outside the loop at the very start. Private logic update of end. This is the main bucket. If nums mid is less than equals, this could be at the mid itself. By doing end is equals to mid minus 1, you skip the minimum. Correct is end is equals to mid. Minimum is in the half, including mid. Okay, wait, we have to understand that there's three conditions. Outside the loop or very start, or I would start now. Okay. Hmm. Oh yeah, we can check for it outside the loop, right? Because we are just comparing start is less than or equals to end. Nums mid. If nums mid is less than nums start, the minimum could be at mid itself. So yeah, maybe could be. You skip the minimum. Correct is mid. And that's this. If nums mid is less than or equals to right, less than. Standard approach to press mid with num set, not num start, because then tells you whether the right half is sorted or not. Minimum is right half. Okay, yeah. If it's more than equals, right? Because what happened to the code? Okay, I mean, if mid is more than n, that means it is the unsorted part, right? If uh, oh yeah. This is for unsorted, right? This is for unsorted, right? Yeah. Okay. Time complexity will be big of log n, right? Oh, purchase premium. It was not that difficult, but we did take a help of AI. Time complexity will be Duka login. Alright. Tell me in one line. Okay, we did our second problem today. Yeah. It's time complexity of big of login. Second new problem we did the second new problem. Okay, I'm going against the roadmap. Second new problem. Solve. Name was find minimum in sorted error. Rotated sorted error. Now I think we should check for the next part of it. Find minimum in sorted errors. Rotated sorted error second. Search in rotated sorted. Find it. Okay, wait, I think. Oh, we have solved this. What is marked as hard level? Is it that hard? Okay, there will be duplicate values also. What should we do next? Before that, you tell me how much I was able to solve this problem. Okay, 80%, 80 to 85% by one. Gaps were small but important. Comparing nums mid end instead of start. Updating it end is equals to mid instead of mid. Okay. Syntax cleanup around if else. Okay. Find minimum tricks. You can't decide string and minus minus. Trick when nums mid is equals to nums end. Okay, would we be using a function mm, to exclude to exclude duplicates, like continue function to filter the array. Okay, key difference, normal case. If nums mid is equals to nums end, you can't decide which is unsorted. So just swing the boundary. Okay, while start is less than end, mid becomes, we calculate the mid, right half sorted, okay, left half unsorted. Duplicate case. In the duplicate case, if mid is equals to nums end or nums, okay, if it's more than nums end, that means right hand half is unsorted. If it's less than the end, then that means it is sorted, right? So we get to that string end minus minus. Okay, we are changing the end boundary. Okay, so then why it was a hard loop problem? And then why it was hard level of problem. Mm, Duplicates break the bug clearing bunny search guarantee. In no duplicate version, every comparison or clearly tells you which side is unsorted. With duplicates, you lose the clarity. Okay. You can't decide which side has the pivot. You forced to shrink the boundaries. Worst case normal, but with duplicates, in the worst case, you keep shrinking one by one. That degrades to big of n. So the problem is hard because you must realize bunny search doesn't always guarantee enough time here. Easy to skip the minimum. Good way. Yeah, first I will write that. By doing that, it will remove the duplicates, right? But duplicates can be in this. Okay. Suppose this will be the searching window, this will be the start, this will be the end. If that is true, then we will shrink the window again and again, right? Okay. Without duplicates, easy media. Every comparison clearly tells which side is sorted. Always log in. With duplicates, it becomes hard. You lose information. You can't decide left or right is sorted. Only shrink. Only after shrink. Worst case, big often. Check mid versus end. A draw an example is given here. Okay, at first I think we should write the code. So inst is equals to 1, no 0, and is equals to num dot size minus 1. But just but we are supposed to think about the logic by own, right? This is not the right thing. Nums and okay. If nums mid is more than nums and right, means we have to check for it in the right side. That means start is equals to mid plus 1. Mm, else if and is equals to mid minus 1 in the less than case, and else if that's equals to that value, so and minus minus. In the end, what we return, we have to return start a value. So it will be nums at start. Mm, mm, mm. Oh, we forget to calculate the mid. This mistake is happening so much times. Plus and minus start divided by 2. Oh, why we shrink the boundary. But yet it's given as 0, right? Like in this case, eventually we will be at a point in the end where start and end will be on the same value. That is 2. But we have to return 1, right? 2 to 2 up to 0. Okay, at 0 is the minimum. So 2's are gone. This will be okay. We're starting the start. So like in this case, eventually we will be at a point in the range, okay, array where all the tools will be gone, and only we will be left with 0 and 1, right? And at that point, start and but suppose this becomes the start, this becomes the end. We calculate the mid. Mid will be this. If mid is if mid is more than nums and right, means right is unsorted. We are all so we will check for it in the right snippet. There is only one value. So we do okay, start is equals to mid plus 1, but this is the mid. So when we start will come at this point, it will surpass end, right? So it will surpass end and we will be at that index. Okay. Like I think this is same a little bit same as the pirate the search index problem, right? So okay, let me ask it at the point that and at that point start will be pointing at 0 index value and end will be pointing at 1 index value. Then we will again calculate the mid, and mid will be mm, less than end. Then we go in the right side, but when we will do start is equals to mid plus 1, then suddenly we will be out of the loop because but we are returning start, right? And return start. Oh, ambiguity. Both of the sides may feel like they are sorted, not equal. Easy decision. But if it was 2, then mid was 2, end was 2, nums. Okay, confusion. So to break the ambiguity, we shrink the boundary, right? Like the ending boundary. Means ignore one duplicate and minimum will be beside that. Okay. What happens in a thought process? Yes, the thing I said, eventually all the two will shrink and we will be left with 0 and 1, right? At that point, oh, okay, 201. Yeah, I was also thinking about that because only two twos will be removed, right? Midpoints 0. Loop end, start will land at minimum. Start end, oh, okay. So mid will be this, yeah, mid will become this, and then we will check that. So 3 divided by 2 is 1.5, but it will be 1 because we are checking for like integer and it will be integer. So 1, okay, not this. This will be the mid, right? This mid is now do the try run on this. Also tell the position of start, end, and mid. Okay, initial start is 0, nums. Okay, mid is 2. Compare nums mid 2 with nums end. So 2 compared with 1. Pivot is in the right because mid is more than nums end, right? So it is will be in the right. Now start is 3, end is 4. Means start is this and end is this area. Okay. Step 2, mid is equals to 3 plus 4 divided by 2, that is 3. Nums 3 is equals to 0. Compare nums mid. 0 is less than 1. Pivot is in the left, end is equals to mid 3. And now start is 3, end is 3. Loop and start is equals to end is equals to 3. Nums 3 is equals to minimum form. How? Oh, okay. End is equals to mid. Final answer is 0. Okay. Okay. In that case, duplicate will be not used. Okay. So now we will understand for this example. In that way, it will be clearer. Okay. Start is 0 and is 2. Step. Okay, we are checking, right? If start is okay, let's think this step 1. Compare mid 2 with nums and 2 equal case. Ambiguity stream boundary. End is equals to 3. Start is 0 and is 3. So because mid was equals to end, so this became 0. So end became 3. 0 1 to 3 and start is at 0. So 0 to 3. Step 2. 0 plus 3 means 2. Compare nums mid with nums end. 2 pivot is at right. Because 2 is more than 0 means it is in the right side of the array. Then in that case, start becomes 2 and end becomes 3 means yeah. This is the start and end, right? 2 and 0. Mid is 2 plus 3. Okay. 2. Compare 2 with 0. 2 is more than 0. pivot is at right. Start is equals to mid plus 1. 3. Start is 3, end is equals to 3. Loop ends. Why the loop ends when start is equals to end? Like we, oh wait, like we aren't even checking for that. Okay. Okay, we did use start is less than end. Okay. Means it will always be that. Like when we find start is equals to end, then that will be considered minimum when after keeping thinking the start space, there will be a point when start is equals to end. Okay, it's okay. Okay, after clicking start and end, converts to the same index. That index is guaranteed to be a minimum because binary search logic keeps discarding sorted halves and focusing on the sorted pivot side. Okay, so it uh, discards the sorted part and keep printing the unsorted part until start is less than end. When they will be on same index, then we will be out of the loop and can return start and as well as can also return and right. Okay. Why we can return both? Because both will be on the same index. Means though both the pointers are on same index, right? If you want, you can return num start, or if you want, you can return nums, and both will be correct. Correct. We got the logic. No wrong answer. Hello, hello, man. Welcome to the stream. Hmm. Answer, is there any? Do you come daily? Yeah, I have come on a daily basis and solve practice DSA problems online and try to explain to all of you, like who comes, like all of the viewers who watch me. Mm, okay, then subscribing you and I will join in daily. Okay. What about you? Are you a college student or something? I also, the time is not fixed, but I usually come around 7 to 8 p.m. Mm, okay. So you are in first year. It feels like that you are in the first year. Oh, mm, okay. You know, I will not recommend you to like just. I will not say that you should just subscribe to the channel right now. You can subscribe it when you feel that okay, this guy is teaching something good, or I'm learning something from him, or getting some value. For now, I will say you can just join the Discord server. There you can share your daily progress, like what you are doing on a daily basis, and you can share a part of a project, or maybe if you have completed a project, you can share it on the Discord. Like I'm trying to create a community of good people who help each other grow together. So you can share that, and we can review that and also do some new things. I will recommend you to join the Discord instead of just subscribing to the channel only after I say go and subscribe to the channel, right? And there are so many people like you in that Discord also. These are also some viewers who are in college, or maybe yeah, they are giving interview, or and they are from different states of the country. They are not from only one state. Uh, I will say I'm just the first sem will start in the month of August. Mm, start. Yes. What about you? Joined. Okay. And can you tell me like why you like quickly subscribe to me? Like why you done that? Okay, seven some. No enjoy. Yeah, we can have some enjoyment, but maybe you feel boring when I will solve some questions in between. I will keep doing the interactions with you, but maybe you can feel boring in between because sometimes I get stuck in a problem and I do the debugging of it, or maybe use AI for that. Maybe it will feel like a little bit boring or very bad, but and I can also not use Hindi because I have made a rule to only use English in that because I also have to improve my communication skills. No, you are crazy, man. What about you? Are you also learning DSA or something? You are in, or you have other technical skills? Okay. I'm also just a beginner. If I show you, this is my profile. Just string. I will start doing strings questions from tomorrow. Me too, beginner. What about you? Like, have you completed basic arrays, strings? Oh, what? Okay. So I think you are on recursion or something, right? Or you are you feel like you are on any other level, right? No, leave that. Okay. Hmm. So you are just learning DSA, or you are learning something other technical skills like you are in or uh, web dev or web development learning. And sorry, maybe I will be getting stuck in between because I was thinking about this problem all the time, and between you came, That's why I am getting stuck. So no, you don't want need to say sorry. I was asking like, are you learning any other technical skills beside that? Like, are you in web development or any other field in which you are learning something? I have to go. Okay, fine. Oh, bye bye. Yeah, any mistake left insert. Okay. Hmm. Left sorted case. If else. Left sorted. And is mid minus one. It was right. Oh, what happened to this string? What code is this? I think there is mm, oh man, I just I'm just writing code for another problem, right? We were solving this problem. Hmm. I gave you the code of another problem by mistake. Not this. Hmm. That means minimum is Okay, minimum is mid or left side of it. Okay. So in the left sorted, we will do and is equals to mid. Its time complexity will be big of log n, I think, because we just use simple binary search. And the third condition was that if mid is equals to, but in the else case, it will not be more than n, it will not be less than n, then it will be equals to n, right? Yeah, because you're comparing it with the end value. Okay. You mind if I share something? I update something. Yeah. Yeah, you can share it. And first of all, welcome to the stream, man. Are you here? Are you here? Hello. Third new problem solved. Don't know where that guy is gone. Okay, I think we have done three problems, right? No, man, we have done only two problems. Second new problem solved, but first problem revisited, second problem, third problem, second new. It should be first, right? Yeah. I will just remove this and name it as second, right? So second, a new problem solved. I don't know why where this guy is gone. Hmm. अच्छा 28 wait. 7. Who's this man? Mansur. Okay, someone joined the Discord, but he's a random guy. I don't know from where he joined the Discord. Oh, wait. There are some people who are just trying to promote themselves, I think, but I will not say that that's promotion because just they are sharing their Twitter account handle or like and said that okay, we are doing 30 days DSA challenge, right? I think that that's fine. If there will be a spam of that, I will try to stop that, or maybe I will create another channel for that as a support channel in the Discord, right? Like you can see this guy, and there was also another guy. So I was thinking that maybe I will create an support channel in this, and there new people can come. Like if new people want to share their that they can share that, and also people can visit their IDs or other like handles. Maybe they share social media handles or other things, so people can visit that also. But this is in general, right? Like there's just sharing. Okay. Yes. Hmm. One view. You mind if I share something? Need some feedback. Don't know where that guy has gone, and he just like disappeared very quickly. Like this guy who came in the stream. Like I think I was just 2 or 3 seconds late. After that, he's gone. But we can't do anything because yeah, we were focusing on the problem. Okay, those things will happen. What? Hey, can you tell me why we also include mid into range, like in both the problems? We did that part one to why we include mid because nums if nums mid is less than nums end, okay, means we have to go in the left. Normally binary search, if we find target, okay, if it's not equals to target, then we may discard mid and equals to mid minus one, or start is equals to mid plus one. Left minimum, okay, when we but in minimum find problems, situation is different. Mid minimum can be on the mid, right? If end is equals to mid minus one, then we will skip to mid. Okay, this the start is mid is this 5 and 2. 5 is more than 2, pivot is at the right. Start is 1. Start, okay. Mid plus 1 means 3. Okay, here, this start and end. 1 is more than less than 2, pivot is left, and is equals to mid. Not mid minus 1 means, okay, I'm just thinking where is that guy gone? In between, I have just like getting a feeling maybe he's back or something. Yeah. So, okay, and is equals to mid, not mid minus 1, not start is equal to 3, right? And is also at 3 loop ends. Okay, we found the minimum. If we have done that, end is equals to mid minus 1. Okay, if we have done that, and is equals to mid minus 1 mean this mid was this, then it would have become this, right? Okay, so if we have done that, then start is equals to mid minus 1 means we skip का check for that value. Okay, So by including it, we will be in the right for checking range. Yeah, minimum can be at mid also. If it's less than or more than, we keep moving left and right in the area after when we um, find that is left unsorted or right. Then in that area, you just keep uh, shrinking and moving left and right, and eventually left with one value. Like, for example, we found, for example, we find, okay, right is unsorted. Right is unsorted. Then we just go in the right and keep searching for the value at that side, discarding left side permanently, and just keep shrinking the surface in the right side and the left, and there we do left and right. Yeah, and we shrink the unsorted part till there's only one element left. Okay. Like at every step we are discarding the sorted part. Unsorted side, we keep shrinking the unsorted side, and finally there will be only one element left, and that will be equals to start and also the end. So we will return that because we are running it till start is less than end. But then or accepted even after I use this. I think that will be fine, right? Because when start we try to cross that. Normally, okay, yeah. In that case also, mid will be is supposed to start and conditions. And that's where loop will automatically break, right? Yeah, I was also thinking about that. It can be redundant iteration. Also thinking about that when I write that it can't be equals to. Okay. If we update and it will be mm, but wait, don't we like at that point when we will again do that doesn't okay, but we are comparing mid, right? Yeah, but mid will be also that mid is equals to end. Yeah. Oh, oh. After that end comes one step back. No condition false, no terminate. Key inside. Okay, so because of that, so I got it right. Now tell me how much I was able to solve these two problems. I think we have I haven't understood it, right? Okay. Net result. Okay. We solved 90% logic by self. Okay. Just there was a boundary updation correction needed in find minimum in sorted array second. Search in rotated sorted array. No, no, I am talking about find minimum part one. No, man, no, no, wait, wait, wait. Mm, hmm. I don't know why. Maybe because of wait. Yeah. Okay. In the part one problem that we did was find minimum in rotated sorted array, right? In that, it said that okay, we cracked that 90% by itself. Just there's a boundary update needed instead of end end is equals to mid instead of end is equals to mid minus one. Okay, that was needed. In part two, it is again saying that we were able to crack 85 to 90%. And we also understood the duplicates and minus minus. Okay, there was again that boundary mistake. But how? Like I was seeing your code, how can you say that? Like how you felt that I can consider that I have done both problems by self. Okay, we pick the core intuition by self. Sort side discard. Okay, we have to discard the sorted side and sorted side shield string. Started and converge. Okay, yeah. We did the dry runs and understood that loop will terminate when start is equals to end. Okay, we by self identify duplicate case. Okay, I think in between the chatting he's considering uh, after that. Okay, we repeatedly raised out and boundary updates. Yeah, we are trying to understand the logic in detail. Uh, okay, not just blindly copying the code. Our mistakes, part one. Okay, in part two, initially the mistake was same, and after that, yeah, inner duplicates and minus minus. Means it is saying that I have cracked 90% of the logic by self. Just there was a boundary correction needed. Okay, that's what is saying that I built a conceptual framework by self. Okay, we did the dry runs and reasoning by self. Okay, okay. Second new problem still. Now I think we can summarize the string, right? Mhm. So if I summarize the string, what we have done in the day 38 string was first we solved a new problem. Name was next permutation. We did it using for loops and time complexity was equals to big of n. Okay, the first new problem was done. Then after that we revisited two problems. The first I revisited was on Geek for Geeks. Name was aggressive cows. Okay, we did revisited that, but not wrote the code of it. Just I tried to explain that what is happening in the code, what we have to find, and just submitted that. And the second problem that we revisited was also similar to that. Just the name was changed of the problem and the variables. And name was of the second revisit was magnetic force between two balls. And time complexity of both of the revisits that we have done was like the aggressive cows, the first problem that we revisit, and the second problem, magnetic force between two balls. Both time complexity we can say in short is equals to big of n log n. Okay, if we say it in short manner. And the third problem that I revisited was search insert position, and we did revisit that after yeah, I wrote the code and also did understood by self, not using AI, because yesterday I told that okay maybe I will try to understand it again by the help of Copilot, but we didn't do that. Instead of that, I tried to understand it by own, and I was able to understand that. So the third revisit was of search insert position problem. and time complexity was equals to big of log n, because we just used a simple binary search in that. And after that, okay, wait. Okay, it will be third, right? I was also thinking that I have done three new problems, but like two new problems, but yeah, we also did the next permutation, right? I forget about that after the revisits. And yesterday it also happened like this. So we did this, right? So after that, after the third revisit, I solved the two new problems today. The first one was find minimum in rotated sorted array. Okay. So we did it using binary search and time complexity was equals to big of log n. After that, and it was a medium level problem that we have done. After that, I tried to solve find minimum in sorted rotated sorted array part 2, and it was a hard level problem, and its time complexity was equals to big of log n again. Okay, because we just used simple binary search in that. So we can say like both of the second and third new problem that we have revisited, like solved, was similar, just there was some conditions changed in both of these. Like in the first part of find minimum in rotated sorted array, we were not handling duplicates, but in the second part we were handling duplicates also. Okay, this was all for the that we have done in today's stream, right? Let me just update the code. Hmm. So if I tell it about again, then we in total we revisited three problems and solved three new problems today. And it was supposed to be only solved one new problem today according to the roadmap, but we also solved two new problems after that. And also in that we solved it using like binary search. But we did take help of AI in that, but these were just some conditions, right? That doesn't matter a lot, but yeah, we have to in the upcoming streams, we have to reduce the use of AI, right? Like what we did in the previous streams, like that. We have to follow that pattern. Mm, don't know why it's not updated. Okay, wait, we have to refresh it. Uh, so in total, we revisited three problems and solved three new problems today. Okay, let me just check. So first we solved the first new problem. Name was next permutation. The time complexity was big of n. After that, we did our first revisit of today. Name was aggressive cows. And after that, we did our second revisit of today. Name was magnetic force between two balls. And time complexity of the both first revisit and second revisit was big of n log n. And after that, the third problem that we did revisited was search insert position, and its time complexity was equals to big of log n. After that, I solved second new problem of today. Name was find a minimum in rotated sorted array. Its time complexity was equals to big of log n, and it was a medium level problem that we solved. And also, yeah, the first problem that we solved today, the first new problem that we solved was also a medium level problem. Okay, and the third problem that I solved today was find minimum in rotated sorted array part 2, and it was also an hard level problem and time complexity of that was also big of log n, right? So in total, we revisited three problems. After that, we solved three new problems, and inside those three problems, two problems were medium level, and one problem was hard level problem, right? And yeah, I think from tomorrow's stream, I will be starting. Yeah, I will start strings. If I show you the playlist, the problem that we done today was that. See, we have already done this problem before, so I haven't chose that. And also we did this problem like in this lecture. The first problem I have already done that. Name was merge sorted arrays. Okay, but we have already done that, so I thought to skip that just I have seen the video. Like the lecture of this was also completed by me and this also. But the second problem was next permutation that we haven't done, so we done it today. Right, this is done. After that, this is just a lecture of about STL, STL containers, or functors, or iterators, or like standard template library of C++. Okay, I will see that. After that, you can see after that just strings has started. Okay, right? So yeah. So for tomorrow, from tomorrow we will start strings, and I think that will be fun, right? And I think we have done a good number of problems in binary search, and and we will also solve the problem search in rotated sorted array part second, right? It is also pending, so we will see that also. Okay, and yeah, I have to mark it as solved in here. Part 3, right? Yeah, next permutation was solved here, so we have marked it as solved. So I'm thinking to solve this problem for a very long time, but yeah, we will see that. Like its name is find the duplicate number. Okay, in this I think we can do it using binaries. Okay, two pointers and binary search. Okay, we will see that later in another stream. So this was all for today's stream. If you learned something from this stream, you can. Okay, sorry. Uh, for now, you can like the stream, and if you feel that you learned something from the stream or getting some value, and if you feel that okay, this guy is teaching something good, and we are learning something from him or getting some value, then you can consider subscribing to the channel only after that. Okay. I will not say that you should just directly subscribe to the channel. Only after I say go subscribe to the channel. Okay. You can subscribe only after you feel that this guy is genuine and he's teaching something good, and we are learning something from him. For now, I will say that highly recommend that you should join Discord server. Yeah, but before that, why I'm saying that you should subscribe after you feel that I am uh, providing some value, or you are learning something from me or getting some value, because when you will subscribe, after that what will happen when I will be live again or like upload some new videos, then you will get notification in your home feed or notification section that I'm live, and you can come back again and see me solving these problems or getting stuck in the problems and try to debug it, and how I think when I get stuck in a problem, and see me explaining the things like other problems and things, because we did also explain today's problem right here, like the first problem that we did also explain it using xcali draw, right? So you can do that, but I will highly recommend to all of you to join the Discord server, because in the Discord server what will happen, you can share your daily progress, like what you are doing on a daily basis, and you can share a part of a project that you are working on, or maybe you have completed a project, so you can share that also, and you can have interactions with other members of the Discord. Like I'm trying to create the community of good people who help each other grow together. Okay, so you can join the Discord server for that. You can ask questions there, and like it is type of a ecosystem. It is type of a community where there are good people there. Okay, just the community is not that bigger right now, but I think with time the number of members will increase with time, right? And we also, and I will say, uh, please do give reviews in the comment section also, like what things should I improve, what things should I work on, like should I add something new in my stream, or should I explain the things using a different approach, or should I use Excalibur more, or should I come up with another approach? Like you can tell me that also in the comment section. Okay. And in the end, I will say, till then you all have to wait. So let me just check if it's okay. 20 fine. So till then, you all have to just keep learning, and you all have to just keep exploring new things. And what was the last thing was that, yeah, you all have to just keep grinding, right? Just keep grinding, man.